Here's the handout that we're going to be working on today. And I'd only like you to work on problems numbers 1, 2, 3, and 4, because that is dealing with the branched alkanes. We haven't yet gone over the rules for the alkenes, and alkenes are going to have double bonds, which we haven't gone over quite yet. So please only do problems numbers 1 through 4 and follow the rules. What I'd like you to do is to attempt to do each of these two and these two as well. So for this, you're trying to find out the name, and for these, you're trying to find out what the structure looks like. I'd like you to, again, review the rules, go over the prior examples. I want you to attempt these. This is your practice at trying to get this without walking through it. I want you to attempt everything first, and then this is going to be a walkthrough. So I'd like you to go ahead and right now to pause the video and to attempt problems 1 through 4 and then come back. Okay, hopefully you have now finished problems 1 through 4. This is going to be the walkthrough. If you didn't do it, what would be good is if you want to hang around for doing this one problem and then attempting this one on your own, and then we can go over this one, and then you attempt to do this one on your own as well. Okay, so first let's go through problem number 1. We need to find the longest parent. So we're going to try to find the longest continuous string of carbons. So for example, I see some things going across and some things going down. So I'm going to go 1, 2, 3, 4, 5, 6. So if I did this, I have a continuous string of 6 carbons. If I went across and then down and then across, it would be 1, 2, 3, 4, 5, 6, 7, which is larger. Let's see if there are any other combinations. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So it appears that 7 is the longest chain. So I'm going to go ahead and block out my 7 carbon chain. And again, 7 carbons is going to be called heptane. Again, all parents are going to end in A and E. So now what I need to do is I need to number these in the direction which the side groups, or my alkyl groups, are going to get the lowest number. So if I start here with 1, it's going to be 1, 2, 3, and it's going to be 4, 5, 6, 7. If I go this way, it's going to be 1, 2, 3, 4, 5, 6, 7. Either way, it doesn't matter for this one. So just to make it easier, we read from left to right. I'm going to be numbering these in this order. 1, 2, 3, 4, 5, 6, 7. Now let's go ahead and name my side groups or my alkyl groups. I have a methyl and I have a methyl. So nothing needs to be put alphabetically because there's no ethyl, there's no propyl to accompany this. So now I need to go ahead and name it. Now remember, I have 2 methyls, so I can't just write it as methyl, it has to be dimethyl. And I also have to indicate the carbon numbers that they are attached to. So I have a methyl attached to 3, I have a methyl attached to 5. This is going to be 3, 5 dash, and it's going to be not just methyl, but I have 2 methyls, so it's going to be dimethyl, and then I use my parent, all one word, heptane. So I'd like you, if you haven't already done so, try to attempt this problem here. Hopefully you've done so. And we're going to go through the steps again and see if you got this one correct. This is a lot more complex than this one is over here. Let's go ahead and take a look. We're going to try to count the longest parent. So we can do it 1, 2, 3, 4, 5, 6, 7, 8. We can go that way. We can go 1, 2, 3, 4, 5, 6, 7, 8. That can also be the same parent. And if you notice, we have 3 carbons going off over here. We have 3 carbons going off over there. So it actually would be the same either way. Are there any of the longer combinations that we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There seem to be 7 combinations, but 8 seems to be the longest. We can either go down like this, or we can go across like this because they both have 8. And again, these could be interchangeable, and so therefore it doesn't really matter. So let's go ahead and block it off as the 8 going in this orientation. So now what I need to do is I need to number my carbons. Do I number my number 1 on the left, or do I number my number 1 on the right? If I number 1 right here, that means my side groups are going to be 2, 3, 4, and 5. If I number on the right, it's going to be 1, 2, 3, 4, 5, 6, and 7. So the lower numbers for the side groups are going to be if I order this as carbon number 1 right here. So it's going to be carbon number 1, 2, 3, 4, 5, 6, 7, and 8. So now I need to name and order my side groups. So I have a carbon here, that's going to give me a methyl group. Here are 2 more carbons, and each of those are going to be methyls based after methane. I also have a 2 carbon and 2 carbon. These are going to be ethyls. So I have methyl, I have ethyl, and then this one is going to be a propyl. So the tricky part is going to be when I have multiple of the same side group, like I have 2 ethyls, I have 3 methyls. So first of all, which one gets the first place in the name? We have to do this alphabetically. We have M, E, and P. So this is one that's going to be going and written first. Methyl is second alphabetically, and propyl is going to be third. And of course, I have an 8 carbon, so my 8 carbon is going to be named an octane. Now also, with my ethyls, I have 2 of them, so I have to list them where they are. They're at 4, not just 4, but 4 and 4. That tells me where both of them are. So it's going to be 4, 4, and I can't just write ethyl, I have to write diethyl. So the name of this one's going to be 4, 4 dash di for the 2 that are present, diethyl. Now I need to account for my methyls. Where are my methyls? They're on carbon number 2, carbon number 3, and carbon number 3. So we have a 2, 3, 3, and can you guess what the prefix is going to be? Tri for the 3 methyls. Trimethyl. Okay, and then we're going to have a dash, and we're going to have a propyl. Where's my propyl going to be? My propyl is going to be attached to number 5, so it's going to be 5 dash propyl octane. It's a really long name. 4, 4 diethyl 2, 3, 3 trimethyl 5 propyl octane. Okay, that's going from the structure to the name. Let's go from the name to the structure. And again, these are easier. Hopefully you've already attempted these. We're going to go over the first one, and I'm going to give you a pause to see if you can go over the second one in case if you need any assistance with this. But pentane means I have a 5 carbon parent. Methyl means that I have a 1 carbon side chain. Ethyl means I have a 2 carbon side chain. So let's go ahead and draw my parent as 5 carbons. 1, 2, 3, 4, 5. it's easiest just to list them 1 through 5 from left to right, because that's the way that we read. 1, 2, 3, 4, 5 carbons for the parent pentane. So let's just go through. At carbon number 3, I have a 2 carbon. 1, 2. That's my ethyl side chain. And then I have 2 methyls, 1, 2, because I have di, and each of them are at 2 and 3. So I have a carbon here and then a carbon there as well. And that's it for the first one. So I'd like you to draw this next one, attempt it if you haven't already done so, and then press pause and then come back. So same thing, we're going to be drawing the parent. The parent is a hexane. Hex means that it's going to be 6, so it's going to be a 6 carbon parent. And look at here, I have 3 ethyls, which are going to be a 2 carbon, and I have 2 methyls, which are my 1 carbons. So we'll start by drawing the 6 carbons, 1, 2, 3, 4, 5, 6. Number them from left to right. It's just the easiest. 1, 2, 3, 4, 5, 6. You could do them backwards if you wanted to, but then you have to make sure that your side groups are accompanying the correct numbers as well. So let's go in order. At 3, 4, and 4, I have 3 ethyls, or 3 2 carbons. So at 3, 4, and 4, so I'm going to have 1 2 carbon here, another 2 carbon here, and another 2 carbon here. There's my ethyl, ethyl, and ethyl. My triethyl is located at carbons 3, 4, and 4. I have 2 methyls, which are 1 carbons each. They're going to be located at 2 and 3. And just for simplicity, I'm going to draw these up top. We have a carbon and a carbon. Well, of course, I can't draw this carbon down here because that's where the 2 carbon is, but I could draw the 1 carbon down there. I just happen to be drawing them on top. And this is the methyl and the methyl for my dimethyl. And again, my parent is my 6 carbon, and at 2 and 3 I have methyls, and at 3, 4, and 4 I have ethyls. That's it.